Hi, this is Sir Absolon of Math Alas channel, and welcome once again in another episode of Learning in Mathematics.
Geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding terms by a non-zero constant called the common ratio. For example, the sequence 2, 6, 18, 54, and 162 can be generated by multiplying 3 to the preceding terms. Hence, the common ratio is 3. We will use this analogy to find the nth term or the general term of any geometric sequence. Consider the sequence 2, 6, 18, 54, and 162. And note that the common ratio is 3 because 2 times 3 will give you 6, 6 times 3 will give you 18, 18 times 3 will give you 54, and so on. Now, we will rewrite each term in the sequence in two different ways, in factored form and in exponential form. We take the first term. So, the first term is 2, so we can rewrite it in factored form as 2 and in exponential form as 2 times 3 raised to 0. Now take note that we have the first term times the common ratio raised to 0. Take note that 3 raised to 0 is 1. That's why it's still the same as the first term. So any number raised to 0 is 0. So 2 times 1 is 2. Now we take the second term, which is 6. 6 can be rewritten in factored form as 2 times 3. So the 3 there is your common ratio. Now in exponential form, you can write it as 2 times 3 to the power of 1. How about the third term of the sequence, 18? So 18 can be rewritten in this form, 2 times 3 times 3, or in exponential form, that's 2 times 3 squared. Now we go to the fourth term of the sequence, 54. Now you see that 54 can be rewritten in factored form as 2 times 3 times 3 times 3, or in exponential form, it can be rewritten as 2 times 3 to the third power. And lastly, we have the fifth term, 162, which can be rewritten as 2, which is the first term, times the common ratio, 3 times 3 times 3 times 3. In exponential form, that's 2 times 3 raised to the fourth power. We know that 2 represent the first term, and 3 represent the common ratio. We see that each term in the sequence, as you can see, when written in exponential form, the exponent of the common ratio is 1 less than the position of the term. So, in this case, halimbawa, the a sub 3, which is the third term of the sequence, which is 18. So, you see the exponent of the common ratio is 2. That's 3 minus 1. If we go to the fourth term of the sequence, you see that the exponent of the common ratio is 1 less than the position of the term, which is 4. So, in general, we can say, if we want to find the last term or the general term of any geometric sequence, we have a sub n equals, we see that we have the first term. So, a sub 1 times the common ratio raised to n minus 1. So, we can find any n term of geometric sequence using this formula. So, that's how we derive the geometric sequence formula.
Before we continue, Adi, Kuya, Nene, Tete, please subscribe to my daddy's channel, Salamat.
In general, the geometric sequence formula is a sub n equals first term times the common ratio raised to n minus 1. Take note that a sub n is the last term, a sub 1 is the first term, r is the common ratio, and n is the number of terms in the given sequence. This time, we will use this formula in solving the nth term of any geometric sequence. So let's begin. Example number 1. What is the seventh term of the geometric sequence? 2, 8, 32, 128. Now, to solve this, we have to find first the following given. So the first term, the common ratio, and the number of terms in the sequence that we are talking about. So in this case, the first term is 2. We see that the first term is 2. The common ratio is 4 because you see, you have the first term which is 2. 2 times 4 will give you 8. 8 times 4 will give you 32 and so on. Or you can just divide 8 by 2. So that will give you 4. And n is 7 because we're talking about 7 terms. Using the geometric sequence formula, we substitute these values. So we have a sub 7 equals 2 times the quantity of 4 raised to 7 minus 1. So following the PEMDAS rule, we'll have 2 times the quantity of 4 raised to the 6th power. Now, be very careful in multiplying terms, especially that we still have exponent here. So again, following the PEMDAS rule, so we have to simplify first 4 to the 6th power. Now, 4 to the 6th power is 4,096. So, ibig sabihin ng 4 to the 6th power, 4 times 4 times 4 times 4 times 4 times 4. So, you multiply 4 6 times to itself. So, we have 2 times 4,096. So, you multiply that, you will have 8,192. Now, the seventh term of the geometric sequence 2, 8, 32, 128 is 8,192. Let's take example number 2. What is the 10th term of the geometric sequence 8, 4, 2, 1, up to so on? Now, to solve this, we have a sub 1 is 8. The common ratio is 1/2 because if you multiply 1/2 to 8, you'll get the next term, which is 4. 1/2 of 4 is 2. 1/2 of 2 is 1. So, that's why our common ratio is 1/2. N is 10 because we're talking about 10 terms. Now, using the geometric sequence formula, a sub n equals the first term times r raised to n minus 1, we will substitute these values. So we have a sub 10 equals 8 times 1/2 raised to 10 minus 1. Now again, following the PEMDAS rule, so we simplify first the exponent. So 10 minus 1 is 9. So you'll have 8 times 1/2 raised to the 9th power. Take note, we have to simplify first 1/2 to the power of 9 before multiplying it to 8. So we have 8 times 1 over 512. Bakit kaya? Note that 1 to the power of 9 is still 1. Diba? 1 times 1 times 1 hanggang 9 times, it's still 1. Now, the denominator is 2. 2 to the power of 9, ibig sabihin, you have 2 times 2 times 2, 9 times. So, 2 to the power of 9 is 512. That's why you have 1 over 512. Now, this time, we can multiply it now to 8. Now, we have the 10th term, 8 over 512. Or, we can still simplify this as 1 over 64. So, the 10th term of the geometric sequence 8, 4, 2, 1 is 1 over 64. Please pause the video and try these exercises. If you're done, type your answers on the comment section.
That ends our lesson for today, and this is Sir Sunny Bugawisan of Matalas Channel. And always remember, in Matalas Channel, we are making mathematics more easy. Bye-bye! See you again next time!